In this video, we shall discuss on the autocovariance and autocorrelation function of a time series. Now, the autocovariance and autocorrelation function can be denoted as the autocovariance can be denoted as RK, while the autocorrelation can be denoted as PK. Now, for we to analyze this properly, we need to check their properties. We first state their properties. After stating their properties, we still have to prove these properties if they are correct. One, the first property we have is we say the autocovariance is equal to the variance of our time series, and the autocovariance is equal to the variance of our time series, and this implies that our autocovariance is equal to 1. This is the first property. The second property, we have our autocovariance RK is equal to R minus K, which also implies that PK is equal to P negative K. You can call it like that. Also, the third property we have for the autocovariance and the autocorrelation function, we have the third property to be RK is less than or equal to R0, which implies PK to be less than or equal to 1 for all K. So this is the property for the autocovariance and autocorrelation function. The first thing we need to do is to prove this function one by one. So we come here, we write proof 1. The first one on our list states that R0 is equal to 1. And by definition, RK is equal to the covariance of xt and xt plus k. So we can say for k to be equal to 0, we'll have R0 to be equal to the covariance of xt plus k, which is equal to the variance of xt. Also, we can note that we say given the variance of xt to be equal to 1, we have R naught to be equal to 1. That is R naught, which is our covariance, to be equal to 1. So this is simple. Also, we can also remove this xt plus k. So if we have this, since our variance is also equal to xt, since our variance can be written as this and is equal to this, and our variance is also equal to 1, at k equal to 0. So we can have that. So if k is equal to 0, it implies that R naught is equal to the covariance of xt, which is equal to the variance of xt and the variance of xt is equal to 1 since k is equal to 0. So if we include k is equal to 0, this turns to 0 automatically. So we can have this as this. We can have this as this, as simple as ABCD. So this ends our proof, but this is where k comes in. We have xt. So that's the proof for the first one. For the second one, RK is equal to R negative k. We can do it here. For more on this topic, you need to subscribe to this channel. Proof for the second one, we are given RK to be equal to R negative k. So this is what you have to prove. So from stationarity, the covariance depends only on lag k. From stationarity, covariance depends only on lag k. So since it depends only on lag k, we can have our RK to be equal to, let's delete this part. Thereby having this in mind too, we'll delete this. So our RK can give us covariance of xt plus k. Also, R negative k is equal to the covariance of, this can move over to this side. So we can write it as xt, sorry, then xt minus k. So it then means that if this is equal to this, it then means that we can say but the covariance of xt and xt minus k is equal to the covariance of xt minus k and xt. Of course, we say let s is equal to t minus k. If s is equal to t minus k, then the covariance of x and x plus k, we can write it as this. Thus, we can move over to this other side of the board. Thus, if this is true, if what I've written here is true, then we can write thus RK, which is our covariance function, is equal to R minus K. So the next one we go into is R number 3. So prove our number three. That our number three, if you could remember, we are asked to prove how k is less than or equal to 1. From Cauchy-Schwarz inequality, from Cauchy-Schwarz from Cauchy-Schwarz inequality, we can remove this. For more on this topic, you need to subscribe to this channel. For Cauchy-Schwarz inequality, the covariance of xt plus k is equal to, okay, since it's bounded, is less than or equal to the variance of xt multiplied by the variance of xt plus k. So we say but the variance of xt plus k is equal to the variance of st and is equal to 1 for stationarity. Is equal to 1 stationarity. Then we can simply write first to complete our proof or to show. We can simply write r, which is our covariance, is less than or equal to the square root of, since this is 1, we have 1 times 1. So we have 1 multiplied by 1, which is equal to 1. So we have succeeded. We say therefore RK is less than or equal to 1. So we have succeeded in proving the properties of autocorrelation and autocovariance function of a time series. For more on this topic, you need to subscribe to this channel to get more on time series analysis.